Welcome to Patugala College of Commerce and Management. This is Abhijit Paradkar, and today we are going to learn about index number. In this chapter, we are going to learn what is the index number, definition of index number, characteristics, uses of index number, problem based on index number, classification of index number, and methods of index number. Let's see what is index number. An index number measures the relative change in price, quantity, value, or some other item of interest from one time period to another. A simple index number measures the relative change in one or more than one variable. Definition of index number. An index number are quantitative measures of growth of price, production, inventory, and other quantities of economic interest. Now we will see some characteristics of index number. Index number are specialized average. Index number measures the change in the level of phenomena. Index numbers measures the effect of changes over a period of time. Uses of index number. Index number are used to framing suitable policies. They reveal trends and tendencies. Index numbers are very useful in deflecting. Classification of index number. Index number are classified into four major parts. Number one, price index number, quantity index number, value index number, and composite index number. Methods of constructing index number. So here we can calculate index number using two methods. Number one, unweighted index number and weighted index number. So here unweighted index number can be calculated using simple aggregative method and simple average of price relative. And weighted index number can be calculated using weighted aggregated method and weighted average of price relative. Simple aggregative method. It consists in expressing the aggregate price of all commodities in the current year as a percentage of the aggregate price in the base year. Formula for simple aggregative method is P01 equals summation P1 divided by summation P0 into 100. Here P01 stands for index number of the current year. P1 stands for total of the current year's price of all commodities. And P0 stands for base year. Let's see one example. From the data given below, construct the index number for the year 2007 on the base year 2008 in Rajasthan state. So here we have given that commodities, units, price in 2007 and price in 2008. Let's see solution of this question. So here they given that commodities, units, price in 2007 and price in 2008. Commodities are sugar, milk, oil, wheat and clothing. So here we just replace price in 2007 by P0 and price in 2008 by P1 because price in 2007 is the base year and price in 2008 is the current year. So just we need to calculate total of P0 and total of P1. So total of P0 is 3236 and total of P1 is 4351. So now just you have to put all this value in given formula. So formula for index number for 2008 is summation P1 upon summation P0 into 100. So just you need to put summation P0 and summation P1 given formula. So summation P1 is 4351 and summation P0 is 3236. So 4351 divided by 3236 into 100, which is equals 134.45. So it means that price in 2008 were 34.45% higher than the previous year. Now we will see simple average of relative method. The current year price is expressed as a price relative of the base year price. These price relatives are then averaged to get the index number. The average used could be arithmetic mean, geometric mean, or even median. Formula for simple average of relatives methods is summation P1 upon P0 into 100 totally divided by n. Let's see simple example. From the data given below, construct the index number for the year 2008 taking 2007 7 as by using arithmetic mean. So here they given that commodities price in 2007 and price in 2008. Let's see solution. So here they given that commodities price in 2007 and price in 2008. So here we need to just replace price in 2007 is P0 and price in 2008 is P1 because price in 2007 is the base year and price in 2008 is the current year. So we always replace base year by P0 and current year by P1. And formula for price average of price relative method is summations of P1 upon P0 into 100 totally divided by n. So here we need to just calculate P1 upon P0 into 100. So here P1 is 10 and P0 is 6. So 10 divided by 6 into 100 is 166.7. So same 2 divided by 2 into 100 is again 100. 6 divided by 4 into 100 is 150. 12 divided by 10 into 100 is 120. And 12 divided by 8 is 150. So now we need to just calculate total of P1 upon P0 into 100. So total of P1 upon P0 into 100 is 686.7. So we need to just put 686.7 in given formula. The formula is summation P1 upon P0 into 100 divided by n. So here summations of P1 upon P0 into 100 is 686.7 divided by 5. 5 is the number of commodities. So here total number of commodities is 5. So answer is 137.34. Now we will see Laspier's index method. This method was devised by Laspierre in 1871. In this method, the weights are determined by quantities in the base. Formula for Laspier's index method is summation P1 Q0 divided by summation P0 Q0 into 100. Next, Pasch's index number. Pasch's index method was devised by German statistician Paschen in 1874. The weight of current year are used as base year in constructing the Pasch's index number, and formula for Pasch's index number is summation P1 Q1 divided by summation P0 Q1 into 100. Dorbish and Pauli's index number. This method is a combination of Laspier's and Pasch's method. If we find out the arithmetic average of Laspier's and Pasch's, we get the index suggested by Darvish and Bowles. And formula for Darvish and Bowles index number is Laspier's plus Pasch's divided by 2. Fisher's index number. Fisher's index number is the geometric mean of Laspier's and Pasch's index number. And formula for Fisher's index number is square root of Laspier's into Pasch's. Let's see simple example. Given below are the price quantity data with price quoted in rupees per kg and production in quantities. Then find Laspier's index number, Pasch's index number and Fisher's index number. So here, given that price in 2002 and quantity in 2002 and price in 2007 and quantity in 2007. Solution. Solution for Laspier's index number. So in that case, 2002 is the base year and 2007 is the current year. So price in 2002 is denoted by P0 and quantity in 2002 is denoted by Q0. And same price in current year, that is 2007, is denoted by P1 and quantity is denoted by Q1. And formula for Laspier's index number is summation P1Q0 divided by summation P0Q0 into 100. So we need to just calculate summations of P1Q0 and summations of P0Q0. So here we calculate P1Q0 and P0Q0. P1Q0 means P1, that is 5, and Q0, that is 10. So 5 into 10, that is 50. Same thing, 6 into 8 is 48, 3 into 8 is 24, and 8 into 4 is 32. Same as like we have to calculate P0 Q0. So P0 is 4 and Q0 is 10. So answer is 40. Same thing, 3 into 8 is 24, 2 into 8 is 16, and 5 into 4 is 20. So total of P1 Q0 is 154 and total of P0 Q0 is 100. So formula for Laspier's index number is summation P1 Q0 upon summation P0 Q0 into 100. So we have to just put summation P0 Q0 and summation P0 Q0. So 154 divided by 100 into 100. So answer is 154. Solution for Pasch's index number. So in that case, again, year 2002 is base year and year 2007 is current year. So here price in base year is denoted by P0 and quantity is denoted by Q0. Same thing, price in current year is denoted by P1 and quantity is Q1. And formula for Pasch's index number is summation P1 Q1 upon summation P0 Q1 into 100. So we need to calculate summation P1 Q1 and summation P0 Q1. So here P1 Q1 is P1 is 5 and Q1 is 12. So 5 into 12 is 60. Same thing, 6 into 10 is 60, 3 into 9 27, and 8 into 5 40. And total of P1 Q1 is 187 and P0 Q1 is 48, 30, 18, 25. So total of P0 Q1 is 121 and formula is summation P1 Q1 upon summation P0 Q1 into 100. So we need to just put summation P1 Q1 and P0 Q1 in given formula. So answer is 154.54. Solution for Fisher's index number. So here, formula for Fisher's index number is square root of Laspier's into Pasch's. So here, Laspier's index number is 154 and Pasch's index number is 154.54. So square root of 154 into 154.54 is 154.27. So Fisher's index number is 154.27. Thank you.